Okay.
Okay. Yeah, so just because we're a little bit short on time at the end of the semester here, and I want to give everybody some time next week to catch up if they need it, I figured I'd introduce this part to you now, and then you can decide when to do it, whether you want to do it tonight or whether you want to do it next week, and then catch up with other stuff tonight. Let me just open my file here. So I lay out the critical stuff. Op10 has the most work being performed. So I gave you a pretty detailed section as to what to do there. When you cycle through Op 20 through 60, there's less work to be done. And what I mean by that is there's less features to machine on each side. So, and I'm also not really particularly concerned with in what order you do things either. So you can grab whatever side you want to work on and call that Op 20 to cycle through. It's not a big deal. We're going to assume that the stock block that we create has already been pre-machined square to itself, so you don't need to worry about which order you put it in a vise and things like that too. Okay. So we'll just talk about the part a little bit first. So your Op 10 surface is up here. This is your top, okay? So this is where most of your work is going to happen. All your drill holes and everything from this side are going to be from this side because you'll notice there aren't any features on the back. Okay, so you're going to drill and counterbore and countersink and break edge and all that stuff here on this side. The stock that I told you is 12.5 by 12.5 square, which means you have a 1/4 inch of material all the way around the outside of the part to machine. And then the way we're setting this up in the stock the first time, just for your reference, I also called out a big enough stock on the bottom, 3.5. I believe the part itself is only 2 3/4, something like that. So you have enough. So basically, you have enough room to hold it on the bottom of the part in a vise. We're not going to set it up, so don't worry about that. I just want to make you aware of it. Where that does matter, and I do call this out, is make sure that you're only going to be leaving 60 thou on the top. Okay, that's your facing material. All the extra stuff is going to be on the bottom, and you're going to take all that off when you flip it. So you'll be taking like a 1/2 inch of material off on the back side when you're doing your last operation. Okay. I should probably open the blueprint too. Let's do that. Oh yeah, I already had that. Okay. So again, all the stuff is dimensioned out. I dimension from the center of the bore. Okay, I'm kind of assuming that the center of this part is basically the datum. Because a lot of the bolt hole patterns and all that stuff are based off the center. So that is also where I call out the WCS, the top. So the G54, its position should be in the center of the 5-inch bore, which is that big through hole in the middle. Okay. Everything else, when you're working on the side, we're going to work in the bottom left-hand corner like we normally would. Okay, so if you picture how you machine this, you're going to touch off on the top, on the side, and then do a 6.5 inch offset to get you in the middle and set 0, or 6 1/4 offset to set 0. On the other ones, when you flip it over, you just touch the side faces, and then that's going to be your 0 point in the bottom left. So with me so far? And I do call that out in the notes too. So if you read through it by yourself, it's all in there. That's all under WCS plane. And again, I don't care which order you do the side faces in. Since we're in here, so as the stock is steel, it's 12.5 by 12.5 by 3.5. The stock should be positioned so at the top has 60 thousandths above the face, like I mentioned, and then the remaining stock should be on the bottom. And then make sure the stock is centered. Okay, that's basically it. Remember when you're doing dynamic milling, especially when you're doing the first couple of operations, that your machining region is going to be the stock. Okay, so what I mean by that is when your very first machining milling operation for this after facing should be this, basically this area here, this face to that hub. That means your stock is going to be your machining region, and this is going to be your avoidance. Okay. Your next one is probably going to be maybe this one. At that point, again, your stock profile out here is going to be your machining region, and then the rest of this area here is going to be your avoidance. Okay. Those are the two main roughing ops where you're going to remove the most material. Once you have those defined and roughed out, then you would just do your finishing operations on your walls and floors. And again, that's all spelled out here. So face off the part, dynamic milling to rough the exterior. There's your 10 thousandths on the wall and floor. How you doing? So then you're going to use contour. Remember, when you're finishing the outside, you can use contour. You don't need to use dynamic mill again. You just basically run the end mill on the outside. Here's that other dynamic mill. So this one might be confusing. So the 7-inch diameter central hub, that's this guy right here. That's what I'm calling out right there. That's 7 inches in diameter. Okay. This one, you're going to have floors to do because this area here is going to be your floor. So this is going to be a finish dynamic, and then you can finish contour this on the walls. Okay. So you can kind of see a theme. You're mostly going to use dynamic mill to rough. Then you're going to finish machine the walls and floors, and then you're going to cycle down and go through it. That 5-inch pocket in the middle, I specify that you should pre-drill that because what I'd like to see you do when you machine that is plunge in the center and then spiral out to get to the finished profile of the 5-inch diameter. So basically, you can go in and find whatever size drill you have that's the largest in there in the whatever tool library you're in, whether it's the ST10 or it should be the ST10. It's probably going to be like 7/8 or an inch. So you can go ahead and spot drill and drill with that, and then you're going to mill out the rest of it. And I don't really care what size you really use, just use the biggest one you can find in there. An inch is probably the biggest that would be reasonable, you know. I don't spell out the strategy, but that's basically what I'm looking for. So if you use dynamic contour in there, you can definitely do it that way. If you use pocket, you may have to find a way to specify the entry point. When you get to it, we can kind of look at it. Because again, you can work on, and this is a group, and you can ask me questions. It's not one of those finals. You're going to contour it, and then I do have some smaller pockets in here, right? So these are a 1/2 inch wide. The way the tolerancing is on the blueprint is I left everything at 3 places, which is ±5. Which means if you have a decent end mill, you could go in there with a 1/2 inch and just follow that path if you want to go down in multi steps. You can't plunge all at once and then do the whole thing like that. Your other option, if you do like to do it that way, is use dynamic, and then you can plunge with a smaller end mill, and then you can do the sweep like I talk about in here. For this one, I kind of want you to play with it and decide. If you do the I call it the contour way of just plunging with an end mill and following that line, you're probably going to have to do some drawing because you can't just contour like one side of this wall here. You've actually got to draw that center line and then tell the end mill to follow it on center. So you may have to play around with that a little bit. After that, it's just a number of different hole sequences. And I don't call the whole sequences out specifically because there's going to be 3 or 4 separate ones. Again, just look at the tolerancing, and I spec everything out on this front view here. So you see we got 1/2 inch holes here. 4 of those. We have 6 drilled in tapped holes. You've used those before. We have 4 through holes with counterbores, which we haven't done a lot of. But basically, I set this up so you have to use a smaller end mill and machine it out like a pocket. You can't just plunge at that size because it's kind of an oddball size. You may find one in there, but I did this on purpose so that you may have to actually pocket that instead of plunge with an end mill. And then, if I remember correctly, I have this wrong. When you go to do these chamfers, I don't think it's 100 degrees. I think it's supposed to be 90. What's the standard chamfer size? Is it 81? 82. It should be 82. You won't find, I don't think you'll find a 100-degree tool in there. So if you can only find an 82 degree, just use that instead of 100. Okay. And then I thought I had a reamed hole in here too. Maybe I don't have, I didn't put a tolerance on anything. I think I may have spitballed it the last time we did this and called this out as a reamed hole, but I don't really care. I mean, reaming, you know how to ream it. You don't have to do that. It's not a big deal. One thing I will note though is take a look at the diameter on this, and then, so if this goes all the way through to the other end of the part, you're not going to find a drill this long. So remember that you're going to want to drill that from both sides. Okay, it's through all, but you can't make it through all at once. So you're going to drill through from each side face on that one. The other side faces just have 2 different series of pockets, one at 3/4 and one at, again, at 3/4, but they're in one's all the way across and one there's 2 smaller ones. So, but yeah, so that's basically the final. It's going to cover everything you've done this semester. You know, aside from like the 5th axis, 4th axis stuff. Okay. Again, it's not that complicated, but there is a lot of tool paths to generate. So it is going to take you some time, which is why I want to give you 2 periods to do it. You know, and if you finish this tonight and over the week, and then you come in next week, and next week is kind of a catch-up week for you, or vice versa. You just look at this today and catch up today, and then do this next week. I don't care how you want to do it.
We still have the class next week, right?
We do, yes. I'll still be there. Yep. So again, just remember, I don't care what the operations numbers are on the side, but just make sure you call them out. They are each going to have their own WCS plane. If you do draw geometry for anything, make sure you label it right in levels. And then just make sure that you do that solid stock first, right, too, okay? But again, once you place the part down and the stock, there's no fixturing, there's nothing else to worry about. You just don't leave the part where it is and just make planes and do planes around. You don't even move the part around at all. Last year, I had a couple people trying to flip it around and getting confused and doing that. Oh, you just put it in place. We're not doing any assembly work, just create planes and just keep machining. This is all about tool paths. I just want to see that everybody can produce these tool paths. That's all. No. Yeah. This is just totally me wanting to make sure you can use all the commands that we went over. Okay. And then this one's worth 100 points. So if you're looking at what you got for work coming out to you, you know, this thing is basically worth 10 labs. So you definitely want to finish this one first. Okay. And I am going to try and grade it before grades are due so that you have a chance to correct stuff if you need to too. This is still a multi-submission thing. So you can submit it, get whatever, and then fix it at the end too if there's time. Okay. All right, so you're off the tent. So you go nuts. Whatever you guys want to do, let me know. I'm available for past work or to help you with this. Okay. So that's the one we did last week. Yeah, the wheel was the last one. So what I was thinking about doing was doing the 5th axis version of the wheel today, which would have been cool, but it would have repeat what we did last week, only in one operation. So it would have been neat to look at it, but I was looking at this too, and I'm like, I think if I just give you 1 period for this, you're gonna puke on it. So I figured let's do this instead. If we all finish this week, then maybe next week we can screw around with the 5th axis version of the wheel. Any questions, Matt? Does that make sense?
Yeah, that does.
Okay, perfect. Yeah, so whatever you want to do, if you want to, I'm available for you if you want to redo the wheel or if you just want to start this tonight, you know, whatever your preference.
Okay.
And then Emily, the only thing you missed was the stock. So, you know, there's a good write-up in here. At least I think it's good. So just remember that we're going to do a solid stock in SolidWorks, but nothing else. So just put the part in the stock and then import that in and then just go to town.
Okay.
Yep.
All right,
Yep. And I'm not going to ask for your solid stock setup or any of that. You know, you don't need to submit that. You're just using that for your own reference. And if you really don't care, you can also just skip the solid stock and do the wireframe if you want. But I think you should do the solid stock. It's nice. I think it's nice to have that. I'm just doing the wireframe.
So on the sides, it's just a setup and a Kurt vise, right?
Not even a vise. Don't even worry about the vise.
Really?
Stock.
What's that?
Because it actually, if you go to do it, it won't fit in the vise.
Oh, right.
Yeah, I drew it really big. I drew this like 3 or 4 years ago without thinking about it. And then I went to go assemble it myself, and I'm like, wait a minute, this thing's not even gonna freaking fit.
So we're not going to put it in the vise or anything. Just pick it up.
Exactly.
Wherever
Yeah,
we're going to pick it up, right?
Yeah, just draw the solid stock and assemble it with the stock, and that's it. And then just import that like that. No vise, no parallels, no nothing.
Okay.
I have a tendency to draw stuff too big. I'm so used to working on big parts that like I forget that most of the fixturing files I have are too small. I don't know why I made this big, but I did want to get a lot of stuff shoved into one part though too. So I think if I would have made that like 3 inches wide or something, it probably wouldn't have been fun to work on. So I'm not going to bother recording the rest. I'm just going to stop this for now, and maybe I'll put that up with the instructions